Hello, this is James Keene, welcoming you again to Binary Mechanics Lab. This paper, which was first published in April of 2015, was updated in March of 2019. And since then, the Google Analytics has shown that the paper has gone viral, so to speak, in the physics community. No, it doesn't go not with millions of views like if it's a funny cat trick, but considering that it's a technical paper, there is a huge increment in the viewing of this paper. Let's see if we can figure out why this has happened. The 8 elementary particles consist of 4 matter particles, electron, and 3 right-handed d quarks or down quarks, and 4 antimatter particles, the positron, and 3 left-handed d quarks, denoted by dl. With quantization of space-time and energy in binary mechanics, each of these 8 particles is associated with a spatial object called a spot, which may contain 0 to 6 one-state bits of quantized energy. If a simulation randomly seeds these spots with one-state energy bits, each particle type would represent about 1/8 of the total energy. This exploratory descriptive study reports the discovery that application of the 4 fundamental time evolution bit operations causes redistribution of energy among the particle types, which then exhibit markedly different energy densities. In addition, the distribution of energy among lepton and quark particle types by these time development laws varies as a function of overall bit density in a physical system, as shown in Figure 1. Here we have the proportion of maximum density. Maximum density is when all bit loci in every spot in the simulated space has an energy quanta in it. Zero density is absolute vacuum in binary mechanics. So we start out as we increase the density. We start out with approximately equal our expected amounts, which is going to be 1/8, about 0.125 of the total energy. And we have here 2-bit operation orders, SVUF, where S is scalar, V is vector, and U is unconditional, and F is the strong bit operation. Those are the 4 time development bit operations in binary mechanics. And another one. Now, both of these are not the ones which are physically correct, because if you change the order of the bit operations, you will find that, in essence, they don't commute. In other words, you get different results. Okay, in this study, a simulated 64 by 64 by 64 spot volume was incrementally increased, starting near absolute vacuum using the Binary Mechanics Lab simulator. Bits randomly added to the simulated volume were distributed approximately equally to the spots representing the 8 elementary particle types. Thus, at near zero proportion of maximum bit density at the left of the figure 1 I showed you, each graphed item starts at 1/8 of the total energy, populating the volume. About 1,000 simulator ticks were run to increase the proportion of maximum bit density to almost 1. Notice that as the upper half of the bit density range commences, the proportion of total energy for each particle type eventually trends toward 0.125, and uncondensed phases of energy may be represented. Previous attempts to account for incidence of elementary particle types as a function of volume bit density focused on counting mite or m-bit types related to fermions. These studies revealed that matter prevalence over antimatter was an ongoing process in the present, addressing the previously unexplained matter-antimatter asymmetry phenomenon in real present time. In contrast, the present study counts all bits per spot type, both the m bits called mites related to fermions and L bits called lights related to bosons, roughly speaking, to reveal the remarkable distribution of total energy among particle types shown in the figure. Prior test runs showed that the three right-handed d quarks had approximately equal energy densities. The three left-handed d quarks also showed similar values. Thus, the Dr yellow and Dl light blue data in the figure represent the averages of the three types in each group. In sum, four types of energy spectrum as a function of volume energy density were identified, and each type was associated with a single lepton, the left-handed electron or the right-handed positron particle, or group of three elementary d quark particles, Dr and Dl. Gross inspection of Figure 1 suggests two pairs of particle type energy spectrums over the entire bit density range from absolute vacuum to maximum possible energy density. Now the update that was in March of 2019. At present, the one and only physically correct bit operations order is thought to be scalar, unconditional, vector, and F for strong. Hence, this experiment, which is number 2 in the BMLS interface program, was run with Binary Mechanics Lab simulator with SUV bit operations order, and dramatically different results were obtained than seen previously. And here they are, quite dramatic. In the CSV output files, the position of bits for the proton bit cycle and the bits in the electron bit cycle is given. One can simply compute the distance between those two bit coordinate positions as we are increasing the bit or quanta density from absolute vacuum to total maximum energy density. By the way, in physics, this is a whole new concept. Now, if we then plot the distance between the bits in the proton bit cycle and those in the electron bit cycle, we have this remarkable curve, okay? Where at this lower range, it appears we have an electron-positron gas in perfect vacuum. As we increase the density in the system, we start to see probably low Z atoms, including hydrogen, and this little dip might be the first neutrons, which other data indicates that about that threshold of energy density, we start to see neutrons. And then this a very interesting stair-step decrease in distance between the proton and electron elements in the simulated space, which may indicate formation of neutrons and higher Z nuclei. Interestingly, as the above about zero point 0.6 maximum energy density, we seem to have plasma, which might be indicated by ionization where electron-proton distance increases. Above about 0.75, we get what I'm calling a lepton quark soup. It's called the lepton quark soup because the leptons seem to predominate if you go back to the original figure shown above. New Rosetta Stone. Let's talk about this. Each spatial object consists of three perpendicular spot units. A spot unit contains two binary bits. The M bit might for the fermions are related to fermions, and the L or light bit, which generally, grossly speaking, might be intuitively related to boson type particles. Hence, each spot may contain 0 to 6 bits, and the pattern is called a bit function describing the system state. Here is our spot unit again with the M bits and the L bits as just described. Three spot units then are arranged perpendicularly along the X, Y, and Z axes to form a spot. Different permutations of the binary variables enumerated here give you a spot cube with 8 possible particle types or spot types, the electron being the one shown in yellow. The fundamental bit operations, unconditional, scalar, vector, and strong, applied in quantized time units t, produce exact time development of the state of any physical system. Analysis of the physical representation of the 8 elementary particles has revealed that they are not as elementary as previously thought. Indeed, 4 types of spot units were found to account for the 8 so-called elementary particles, suggesting a new, more elemental level of analysis of physical phenomena, perhaps the most exciting frontier for investigation in contemporary physics. Here are the 4 spot unit types, which correspond to the 4 particle types. Sort of an amazing correlation. Could it be a mere coincidence that the 4 distinctly different elementary particle energy spectrums found in the present study map one-to-one to the 4 types of spot unit reported previously? Consider that the 4 energy spectrums and the spot unit types were derived from completely different sources. The present results are empirical findings running the simulator. The spot unit types were identified by some specific components each spot unit must have in order to implement the fundamental bit operation. In summary, data show that 4 types of spatial objects called spot units are the fundamental building blocks of the universe, and that each of these types is associated with an elementary particle category exhibiting a unique signature energy spectrum measured over the possible bit density range. For further investigation in this cutting-edge frontier in modern physics, one can think of dozens of top priority research proposals. A top priority is to demonstrate that any physical phenomena can be duplicated by the time evolution laws of binary mechanics in the correct bit operation order. Thus, there are opportunities in all subspecialties of physics. Meanwhile, back in the 20th century, let us go back to the past for a moment, much as an anthropologist might presently visit a less advanced tribe to observe their superstitions. In a mind experiment, draw a vertical line in figure 2 or 3, say at 0.5, 0.7, or 0.9 of maximum energy density to depict the latest efforts at facilities like CERN. The boosted Large Hadron Collider energy beams will see things along this vertical line of energy density, a primitive keyhole look at the big picture. News reports say new particles will be sought, but this seems completely trivial in comparison, given that the proton bit cycle can be used to enumerate all possible hadron phenomena on a laptop. Even worse, this research focus goes in the opposite direction, using the LHC instead of a laptop to itemize more macroscopic objects composed of the 8 elementary particles. Now consider this. First, if electron-proton accelerators have achieved velocities very close to light speed, for example, greater than 99% and even much better than that, would this not locate the beam energy density at the far right of figure 3, near maximum? Second, if this is true, then the beams hitting targets are not electrons or protons as commonly understood, but rather a high-energy soup beam, also known as a quark-gluon soup. 3. It follows that these particle accelerator labs do not know exactly what is in fact colliding. Lastly, fourth, hence many supposed particle interactions may be pure conjecture, and the usefulness of highest energy particle collisions as a research tool may have reached a limit. In contrast, in this 21st century, where we all are living now, as the standard model is upgraded with quantized space-time and energy installed, nuclear physics is becoming essentially a bookkeeping exercise, releasing vast intellectual talent and resources in the physics community to address more fundamental questions in science. Will investigators turn around and look at more fundamental microscopic levels and address the challenge of understanding the smallest elementary objects in physics, which appear to be spot units?